have done it. Okay. Any questions before we get started with these slides? These are our last slides on Scratch. We will not learn Scratch anymore in lecture. This is all I have for you. We're going to switch to Python in a future programming lecture. Isn't that fun? So please go to scratch.mit.edu and we will begin. Make sure the tablet works. All right, so yeah, let's just, I don't know, get into making fancier programs, because that's how I want to build on top of everything we learned. Keep on doing fancier things until even those things seem easy. Okay, so the program creation process, let's kind of break it down. How do you create a program that does something? What is the process for all of that? Okay, so here is how I would like to break it down to you. All right, so if you want to write a program and hope that it is correct, right? You want to write a correct program, it's got to perform some certain task. You have to, well, definitely understand the problem, yeah? You need to understand a bunch of things about it, right? How to even maybe do it, all right? You have to understand what you're trying to solve. What is it that I'm trying to compute? What do I need to show the user? Things like that. And you can also break it down in terms of the problem, in terms of the inputs and the outputs that you are getting and that you will give, yeah? So like, I'm going to ask the user to tell me their name so that I can tell them hello with their name attached to that, things like that, okay? So that's input, for example, and output. So all of these things need to come together to make a correct program, right? So the problem itself, what are all the concepts involved? What kind of blocks do I need, maybe? Do I need to loop a bunch of times? Do I need to repeat things? Think about the concepts. Think about the inputs. What will the user give you as they run your program? And then outputs. What will you give back the user? What is, let's say, like, what's the answer that you're trying to give back? For some definition of answer. That's your program just gives back. That's the idea. Any questions about that? Like, seems logical, yeah? If we understand these things, we can hopefully make a program that works. All right, and then you need to combine all these, right? You need to find a way to bring them all together. You have to find a strategy that maps those inputs, right, the things that the user is giving you, to the outputs that you need to compute based on the inputs, right? Usually the program changes and it does different things with different inputs. So it's always, you're sending some inputs to some different outputs, okay? And that whole process is essentially what it means to make an algorithm, right? It's just a sequence of steps. It's all coming together, okay? So that was a lot of words and philosophizing. Does that make enough sense? All right. So the next thing that I want to do is like write a fancier program than we've written. Okay, so let's calculate n factorial. Okay, let's calculate the factorial of a number where the number is user input. Yeah. So let's think about this problem and solving it in terms of all this stuff on this slide, right? So what are we getting as input? The user's giving us a number n, and it's our job to calculate and display maybe, right, the factorial of that number. We remember what factorials are, right? So 5 factorial is like 5 times 4 times 3 times 2 times 1, right? Which is 120, if I remember correctly. And so we can calculate those things. And it doesn't matter what the user gives us, we're going to calculate the factorial of that number. So if they gave us 5, we're going to say 120. If they give us 3, we're going to say 6, things like that. Okay? We're going to compute it on the fly for different numbers. Okay? So the input's a number. The output is also a number. We're giving back the factorial of the input number. And then okay, we have to understand the problem that we're trying to solve. So we're taking a number, we're finding the factorial of it. That makes enough sense. But maybe that's not enough to correctly translate it to a program just yet. If, like, you write down what you're supposed to do and you're not really sure how to do it, the standard way of proceeding from there is to find things called sub-problems. Find smaller problems within the problem that you do know how to solve and that you can combine, right? So let's try and break down. Let's see all the different ways that this program could work or that it could go wrong, right? So, for example, like if the user asks us to find the factorial of -5, that doesn't have an answer. There is no negative factorial. So we're going to have to maybe yell at the user. That could be one way out of this. Tell them, no, we're not going to do a factorial for a negative number, something like that. That's a possibility. And so we break our problem down into these little subproblems. That's one of them, maybe, an error case. Also, we, of course, have the main problem. So the user gave us 5. It's a valid number to want to take the factorial of, or to compute the factorial of. How do we go about doing that? Okay. And so if you think long and hard enough about that, here is one way of doing it. All right. Here's how I'll program it for you today. Let's make 2 variables. We're going to keep n, right? N itself, and we'll make a variable that holds the value that we will eventually output. I'll call it out, okay? So n is whatever the user gave us. That's like, hey, I want the factorial of 5. So it will be set to 5. And then out is going to be the variable that holds what we need to eventually output. And I'm going to start it at 1 because I want to accumulate a number within it. I want to repeatedly multiply 5 and 4 and 3 and 2 and 1 into the out variable. That will solve the problem, right? If I keep doing that. And notice out needs to start at 1 then if I'm trying to multiply stuff into it. I can't start it at 0, otherwise it will never become anything other than 0. So when you're accumulating things, you start that variable at 1 when you're multiplying. That's called your accumulator. And you start it at 0 when you're trying to add, like you're taking the sum of a bunch of things. Yeah. Hopefully that makes enough sense. So yeah, we're starting at 1 so I can multiply into it as many times as I need to. And so here is the algorithm. Here's a good enough algorithm that makes it work. So let's keep multiplying, actually n itself, because that's the only other thing we have in this program right now. Let's keep multiplying n into out, setting out to be what it is currently times that n value. So the first time we will do stuff, we will send the 5 into out. We're going to multiply out by n right now, which is 5, and that will set it to 5. And here's the trick. We can decrement n, make it 4 now, so that now we're ready to put the 4 into out and multiply it into that. All right, then we bring the 4 in. Out equals whatever it is times 4 now, so now it's 20. You see how it's going to build up and become the correct factorial as long as we stop when n gets 1 or 0. So 4, 3, if we decrement it one more time, multiply it into out, that'll make out 60. Yeah. Decrement n is now 2, multiply it into out, so out is itself times 2 now. So that makes 120. And we could stop once n is 1, decrement it one more time, because anything times 1 is still 1. But let's just do it like a factorial. Multiply one more time. 120 times 1, which is 120 still. And then n becomes 0. And that can be our stopping condition. Okay? Then we know to stop this process of multiplying into out and decrementing n. And we can output our out variable. Okay? So we sent all of those numbers into out. We kept on multiplying it. We accumulated those numbers just like that. Any questions about that process? Does it make sense on paper at least? Because we're ready to turn it into code now. Okay? So, let's see here. How do I want to do this? Yeah. Well, let's just go straight to code. So here's what I want to do. Let's, when the green flag gets clicked, ask the user, right, for a number to take the factorial of. So enter a number and wait. And then answer is going to hold their number, right, 5 or whatever. And sadly, I cannot mess with answer like this. I can't decrement it by 1 or anything like that. So it has to be a normal variable, an orange variable. So I'm going to make a variable called n, and immediately after the user gives us something into answer, I'm going to put answer into n, okay? Because then I can touch the n variable. I'm allowed to use all these orange blocks on it, right? Does that make enough sense? I'm just putting answer immediately into n, because I'm allowed to mess with it now. And I'll also make an out variable, right? So now I have 2 variables and an out. And let's see here. What do I also need to do at the very start? I needed to start out n as whatever the user gave us, and out needed to start at 1, so that I can multiply into it and not get a weird looking number. So at the very beginning, out should be set to 1 as well. So we're just starting off our variables with the right values, okay? And then repeatedly, I am going to multiply n into out and decrement n until n becomes 0. That's when I want to stop, okay? So I want to do this process of multiplying into out as long as n is greater than 0. Does that make sense? Strictly greater than 0. That's going to be my test, my condition of a loop, okay? So I want to repeatedly repeat until something happens, the following. Multiply n into out, right? So that is set out to whatever it is times n. So there's a times block. Yeah. And then I need to also decrement my n variable. So then I can like multiply 4 into out and 3 into out. So we will change n by not positive 1, but negative 1. So that decreases it by 1. Okay? Does the body of this loop make enough sense? I'm going to keep on doing that process. And then we need to put a condition here that becomes true when we want this to stop. So repeat until something happens. We need to keep going as long as this was true. So whenever n gets to be 0, then I want to stop, right? Whenever n gets to be 0, I want to stop. So repeat until n is 0, maybe, right? Something like that. Repeat until n is 0. That could work. So repeat that process until n is equal to 0, all of this. So it runs the 2 blocks inside the body of this loop and then checks the condition, repeatedly does that until the condition becomes true, then it's done with the whole loop. Yeah? And then finally, at the very, very end, we can say our answer, because that was our output, right? I know I put it up here already, but we can say out for 2 seconds, because why not? Okay? Any questions about this code? It's a bit involved, right? But hopefully it makes, as I was explaining it, it made enough sense. So let's try it. Let's enter 5. We go. And you could see just for a split second, right? N had some values and they got kind of small very, very quickly. And out is 120. Yeah? Maybe I'll do it again. And then he says 120 for 2 seconds and he's done. And this works for any value. Works for 3. 3 times 2 times 1 is 6. I don't know what factorials of larger numbers are. Let's see what 10 factorial is. Apparently a large number. But it's going to work most of the time, right? So Yeah, we're still good with this code, right? Any questions about it? Because there's something wrong, right? What could I give as n to blow everything up, to ruin our day? Negative. Yeah, if I gave a negative number, will n ever become 0 if I keep decreasing a negative number? No, that's never going to happen. So that's an infinite loop. That's an error right now. So factorial of -3, please. Whee, there it goes. Look at n get so small. And it looks like the out variable is just, it got so big that it hit infinity. And it's just alternating between positive and negative infinity, of course, because we're multiplying by a negative number each time. So yeah, we just have some kind of weird state going on there. And it's kind of stuck. That's no fun. So let's make sure that never happens. Whee. So maybe we should look and see if we get a negative number. If so, we should output an error message, something like that. Yeah, I think that would fix it. So if, let's put it right, I have a spot that I want it, and it's not that one. Let's just do it over here for a second. So if n is less than 0, if n is negative, right, then I don't want to do anything at all. N is less than 0. Then I want to do something like, let's yell at the user. Let's be like, say, factorials don't exist for negative numbers. I don't know how to compute the factorial of a negative number. For 2 seconds. And then we don't want to continue, right? Let's put this right here. And then we go here. So if we yell at the user, we do not want to run this loop, right? Because that's going to get us into trouble again. It's going to continue to it no matter what right now. So inside of the loop's body, I can, inside of this if statement's body, we say, I can just stop the entire program. Is that events? No, it's control. Stop all. So I'm just going to let the program not continue if we get to that error state. Yeah. So now -3. Boop. I don't know how to compute the factorial of a negative number. And stop. Nice. We didn't continue. And it still works. It goes past that if statement. Otherwise, if I give a normal number. Okay? So that seems like a good solution to me. Any questions about it? Of course, I will save it so that I can give it to you. But that's us computing the factorial. We broke it down, and we made a solution. All right. Another problem I have for us. Let's sum the numbers from n1 to n2, where we get 2 things from the user now. Right? So maybe the user gives us 2 and 7, and we want to then, this is the idea, you want to calculate 2 plus 3 plus 4 plus 5 plus 6 plus 7. And that's your output, whatever that value is. Does that make sense? So calculate a sum within a range. That's what we're getting. So that's our input, right? Got to think about that. What's our output? It's going to be the sum of those numbers that are in between all those, also a number. And then, okay, let's break down the problem. We want to sum all the values from n1 to n2, okay? Think about, okay, how could we do it? What could go wrong? What if the user is asking us to calculate the sum of all the values from 7 to 2? That makes no sense. You can't go from 7 to 2 increasing. So this is like another error state. What should we do then? Should we yell at the user? Something like that? We'll have to think about it, okay? And then we go down to the main problem, right? So how do we actually get that sum out? So we have n1, that was like 2, and we have n2, that was like 7, and then maybe we could keep an output variable as well. That's going to accumulate the sum of a bunch of numbers, so it should start at 0. Yeah. And then the question is, how do I do stuff with these variables to get the right answer and out so that I can give it back? Take a couple seconds to think about it while I get a drink, and then we'll talk about my solution. Because you need a way of like doing the same thing inside of a loop, right? It's always, this code never changes, it just does a different thing with a different value of the variable, right? We're doing the same thing each time because we're repeating stuff. We have to have something to repeat. So here is something that we could repeat. Maybe we can take n1, because it starts at 2. That's the first number we need to put into the sum, right? Maybe we can use n1 and just keep putting that, whatever is in n1, into the out variable. Add it in, right? Because that will make it 2. And then, how about I increment n1, make it 3, because that'll be the next number that I want to add to the sum, right? Then I can bring it in. I can bring it in as well. Brought the 2 in, bring the 3 in, now it's 5. The sum is 5. Now n1 is 4. I can bring the 4 in, right? Now it's 9, assuming I'm doing math properly. And eventually, dot, 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 I don't know the answer, but n1 is going to become 7. We're going to add 7 into out. Yeah? And that's the last one we want to add. Ooh, that's a stopping condition. Because the second I make this 8, because I'm going to repeat that process, right? Add in, increment, n1 will stop us if we ever get it to be bigger than n2, which was the end of that range that we wanted to add. Does that make sense? Do you see how that could be translated into a condition on a loop that stops it? All right. So yeah, that's what we noticed. We can add n1 into out while it's less than or equal to n2. We also need to increment n1 each time, because that's the number we want to add in. And eventually, once we're done with all that, we will get an answer into out that we can give back. Okay? Any questions about the idea before I code it up? All right, so all this hard work, goodbye. So we still want we want 2 numbers now, don't we? So n1 and n2. So n is now n1. Make a variable n2. Can I order them? Oh, nice. It's already in alphabetical order. I appreciate that so much. So we need 2 numbers, right? So enter n1. I don't know. Enter n1, something like that. And so then answer is set to the value we want to put into n1, right? And then we'll do it again. Enter n2 this time. And then we'll put whatever the answer's value is into n2 now, yeah? So we're getting 2 numbers. Putting the first into n1, second into n2. And we're starting our accumulator variable, because we're adding, we started at 0, yes? So that's the setup, that's the beginning. And then we do our loop, okay? So repeatedly, let us add n1 into out and increment n1, yeah? That'll eventually do it right. So we'll worry about the condition in a second. So repeat until something. The process of add n1 into out, so set out to be whatever, the sum of whatever it currently is, and n1's value, yeah? And then increment n1, yeah? That's the process that I was talking about. And we want this to stop, right, once n1 gets too large, once it gets past the end of the upper bound of this range. So we want it to repeat until, we don't want to continue, the second n1 is strictly greater than n2, yeah? So repeat until n1 becomes strictly greater than n2, because then it's not part of the range anymore. It's 8, it's not 7. We just added 7. No more after that. Do you see how I'm getting that condition? That's important, because that'll become true when I want this to stop. Repeat until n1 becomes greater than n2. We're never touching n2. We're just getting that. That's our upper bound. That's how we know when to stop. We only mess with n1 in the loop, though. Okay? And so once this loop stops, once this becomes true, it'll bring us down to the rest of the code down here. And our last piece of business is to say the answer. So just say out. Even though it's already up here, who cares? Okay? Questions about this long string of blocks? Is it making more sense than the last one? Less? Let's try it. So enter n1, 2. Enter n2, 7. All right, apparently the answer is 27. Yay. And you see it stopped. Look at n1 up here. n1 is 8, and n2 is 7. And that was our stopping condition. That is perfect. That's exactly what we wanted here. And so apparently the answer is 27. Yay. Now we know. And you can always compare with what you know. This is supposed to be what? 9 times 6 over 2, which is 9 times 3. Yeah, 27. Cool. So we did do it right, and it works for most ranges. What's the sum between 1 to 10? Didn't we do that before? 55. Yeah, that sounds right. And it works for anything. What's the sum of all the values between, I don't know, 50 and 100? 50, 100. These are interesting questions to ask. Oh, that's quite large. Nice. Again, though, what's going to happen if I give a bigger number first? What if I say I want the sum of all the things between 7 and 2? What's our code going to do? It's going to be like, all right, I'll add 7 into out, things like that. Is it going to work? What's going to happen here? 7, 2. Is it going to give an infinite loop? Ooh, this has a more graceful exit because it is our condition that is immediately false, or sorry, immediately true. And so this loop never runs. Isn't that nice? If the user gives you a bigger value for n1, then it's never even going to run the loop. It's like repeat until this. Oh, it's already true. I don't have to repeat anything. Isn't that nice? So you could also have an if statement guarding against that, being like, watch out. Maybe we shouldn't even try to get down here if the user gave us a weird range of values, but it is possible. So go here, and we could do the same thing of stopping the program if things go bad. So the error state was if n1 was strictly greater than n2. It'd be like, that was an invalid range of numbers, dude. And stop the program. We can yell. Does that make sense? So if I do 7, 2, invalid range, and then it stops the program and does not continue and output 0, even though it's not an infinite loop. That's quite nice. And notice it's strictly greater than. The sum of all the numbers between 2 and 2 still works. It's just 2, right? Totally fine. Strictly greater was the error condition. So yeah, that's a big program. Look at it. Any questions about it? All right. So, let's see. I want to save this. Saved away. And yeah, I think we can continue then if we're doing all right. The next thing that I want to show you that will become very, very important when we get to Python later is the idea of making your own custom block. Right? Maybe we just want a single block that does a bunch of stuff, right? Like how did the Scratch people code up the, I don't know, What's a good one to think about? How did the Scratch people make the if on edge bounce block? That's like an if. That's an if block and doing some weird stuff, right? We kind of did this for Pong. How does this block work? Like it seems like it's made of smaller blocks, right? And we're just given a nice one that does everything for us. We can make our own blocks like this that do a bunch of little things. That makes it much easier to reason about your program if we can separate our blocks into small things that look like this. And it also makes it a lot easier to read because we could like make a bunch of custom blocks and have this be a very short program, okay? Where the work is being done by those little blocks. So that is our goal, okay? So we want to make our own blocks that break down problems, right? Goal. Break down problems. Into smaller pieces. And as far as we are concerned in Scratch, smaller pieces can be smaller blocks. Yay. So here's what we'd like to do. Let me make a custom block for us. The first will be sum from 1 to n. So we're going to make our own block that encapsulates this entire idea of adding the numbers between one and another number. So it'll look like this. Let's calculate the sum from 1 to, and then we can give ourselves a little hole there. So we're making our own block, and we can put a value up in there. Isn't that cool? And it'll calculate the sum from 1 to that, whatever that number is that we are passing along. That is our first custom block that we shall make. Okay? Won't that be nice? And then next, we'll make our own if touching paddle bounce block, and we'll do it the right way for our Pong example from before. All right. So, any questions? Any last questions about this before I make it go away? All of our hard work again. Speak now. Goodbye. All right. So, this is the last place we haven't been in Scratch, called My Blocks. It is empty. Let's make a block. It's going to need an input. We are going to do, it's going to need a number input, sorry. Oh, delete, there. Block name, sum from 1 to, and then conveniently the number will be the rest. Hey, won't that be nice? So let's click OK. Now we have this block. We can plug it out here and use it. And it also brought this into our window, which will contain the definition of what we want that block to do whenever we hit it. Isn't that nice? So let's see. And I can edit this. This number doesn't have to be called number or text. It's essentially going to become a variable for us to use. So let's just call it n. And now it's n here. I right-clicked and went to edit. So yeah. And this is secretly a variable inside the definition. We'll get to that. Don't worry. But we just made this block. Let's pretend we have it implemented. Let's use it. Let's be like events. When the green flag is clicked, ask the user, enter a number. We're only getting 1 this time. And wait. We will delete. I don't need that. I guess I don't need any of these, but we'll deal with it as we need to. So enter number and wait. Then we could be like sum from 1 to answer. And we can have this block take care of both computing the answer and printing it out, because this block is not like one of these that can give back a value. It just does something for us. Okay? So it will be a 2-block program, but all the work is going to be done by this custom block that we're making. So this is how we want to use it. Does that make sense? And now we don't get anything for free. We have to say what it means to run this block. What are the smaller blocks that it makes up, or that make it up? Okay? So that's where this definition block comes into play. It says, whenever this block runs, it's going to jump to this definition of the block, and it has this n variable that will be set to whatever you were giving it at the time. So if answer was 5, this n is now going to be 5. If answer was 4, this n is now going to be 4. And this block could appear in many places of the program. You don't have to give it the same value each time, but every time it goes to the definition, whatever you gave at that particular point in time will be set into the n variable. Does that idea make enough sense? This is just ever changing. Whatever you're currently trying to calculate the sum for 1, 2 of, n will be set to that. Yeah? It's like setting the variable for you. It's called a parameter if we want to get fancy, and we'll talk about that in Python, but we just need one version of it right now. So n is going to get set to answer, because that's what we're passing along when we run this block. All right, so how do you compute this? Well, let's just use out again. We'll set out to 0 and then repeatedly add some numbers, right? I guess I need another variable as well. Let's see. I don't want to call it n. Darn. What's a good name for this? Because it needs to decrease, right? Just like we were doing for the other sum. Or for factorial. What's a good value for you? What are we trying to do? I'll just call it n copy. Who cares? So I need to set that, because I need to be able to change a variable. Again, just like answer, this n cannot be set. So I'm going to use normal orange variables for it. So we're just going to set n copy to n, and work with n copy instead, okay? And so here's the process of, I'll just do it quickly, of just adding all the numbers, right? Sum from 1 to something. So we could do, or you know, we could count up. How about we just count up? That would work. And then I can call this something useful, like counter. We'll start it at 1. That's much easier for me. So I'll just keep on adding the value of counter into out, yeah? Or even we could call out sum. I'll just keep adding the value of counter into sum. That seems like the most easiest to understand names of these variables, okay? So counter starts at 1, it'll be 1, then 2, then 3, and we'll keep on adding it into sum as long as it's less than or equal to n, yeah? So let's do that. I think that seems right. So repeat until something. The process of adding into sum, well, whatever it currently holds, plus the value of my counter. And that will work. And then increment counter. So this will allow it to eventually count up. And then we want to repeat this as long as the counter is less than or equal to the n I'm trying to count up to. And so if it ever gets strictly bigger, that means we need to stop. Repeat until counter is greater than n. Then I don't want to add anymore. And then we can output the answer. So we're calling it sum here. So look at this. This is going to repeatedly add counter into sum and increment counter. Okay? And it will stop once it gets too big. It's bigger than the number I wanted to go up to. Okay? So any questions about this code? It's just like pretend we got a number from the user and we put it into a variable called n. That's essentially what's happening for us. It's just done for free by Scratch. And so that's it. Look at the normal program. Like we could give this, like we could secretly give this definition to somebody and they could just use it. And look how simple it makes a program. We worked with all the fancy stuff up here, and now we don't have to think about that fancy stuff ever again when we want to use it. That makes the program a lot cleaner. let's run it. Let's see if it actually does something right. 1 to 10. Yay, so it is 55. It's doing the right thing. And so what happens once we hit this block? Scratch jumps to the definition and sets the n variable to whatever we put in the little circle, which is answer. Okay? So it's going to jump right up here and set n to be answer, whatever I typed along, so it was 10 this time. And then it runs all this code, which is stuff that you understand now. Okay? Any questions about these two pieces, how they're working? We just made our own block. Super nice. All right. I promised that I would do Pong correctly. So let me fulfill that promise. So I'm going to open. I do not remember which lecture we did this last. I assume it was this one, and I assume it was the last one. So let's try this. I did just save this, right? Did I? I don't remember. Let's save it one more time then. Okay, load. Now let's try this one. Yeah, cool. So, what would I like to do? I'd like to make an if touching paddle bounce block. I'm going to add it to my Pong program. And that will replace, let's see here. I guess it will replace this code here. And so if I just wanted to do if touching paddle bounce, I might have to put the change of points in a new place, but let's just not worry about that. Let's just keep it as it is. So if touching paddle bounce. So now it looks like the other one, if on edge bounce. That's pretty nice. So let's put the definition over here. It doesn't need any input. It just runs whenever we run it. And what it needs to do is this. Yeah? And now, instead of doing all that inside of this loop, we'll do it inside of the block, the definition of the block. See what I changed? That's much cleaner looking. Like you can just shove this, like sweep that under the rug, and it's much easier for the user to think about what's going on if they're looking at your program. Isn't that nice? So if touching paddle bounce, what does that mean? Well, every time that block gets run, it goes to the definition, and it runs this code. Technically, it also changes points, but let's just not worry about that. And it still works. Everything should still work. Whee. If touching paddle, bounce. It did it. Yay. Any questions about that? Why it still works just fine? Why it's jumping to that block, that new block that we made for ourselves? All right. The other thing that I promised you is correct bouncing. So right now it's just going 180. Let's fix that. When the ball comes in, it better go off in that direction, right? Right now it's going off in that direction, which is wrong. So let's see if we can figure out how to do that. So let's try some options. So if the ball's coming in at like 45, it needs to bounce off, not at, if it's coming in at like negative something, it needs to bounce off, not at 45, but that number. Yeah, something like that. If it's coming in like this, it needs to bounce off like that. Yeah. It's coming in like this, it needs to bounce off like that. There we go. Coming in like that, it needs to bounce off like that, instead of bouncing off like that. And if you try enough options, you'll notice that like going in that way needs to bounce off that way. Negative 53 needs to go to, oh shoot, maybe positive 53. If it's coming in somehow that way, it needs to bounce off to negative. Oh man, so it's always going to be some number, like coming in that way needs to bounce off this way. Negative 137, positive 137. The way that Scratch has made the direction a number, we can just negate that angle and it will bounce off the proper way. Believe it or not. So instead of turning 180, I can just set direction to negative current direction and it will work. So negative 45 becomes positive 45. That's all. Don't need to mess with angles. So that's, yeah. Instead of turning by 180, point in direction. Instead, please point in direction. Whatever your current direction is, but negated. So is there a convert to negative? Well, I'll just multiply it by -1. That's fine. Point in direction, current direction times -1. Yay. So just the way that the angles are working, we got that for free out of Scratch. It was nice enough to have negative angles, I guess. So let's try this. Oh yeah, that's lovely. That's not a steep enough angle. Let's notice it working a lot better. Oh yeah, look at that. If touching, paddle bounce. That's how Pong should be played. Any questions about why this is doing the right thing now? We got a 2 for 1. We have learned about how to make new blocks, and also we have a perfectly accurate Pong game. All right, and we can still lose. It all still works. Just, it's easier to think about when you add your own blocks. So I'll save that. Questions about that? All right, I have a couple more examples, and that is it. So let me make sure that I don't let us leave before talking about your programming assignment. And then we also have a midterm on week 8, so we'll talk about that too. Okay. Last major idea, let's go back to state machines. Let us make a state machine that gives back an answer of, hey, is the number that you have typed, is that divisible by 5? So we're going to ask the user, hey, give us a number, or give us the individual digits of a number, in fact, and we will give back, hey, that number is or is not, that you have been building up, divisible by 5. So here's the game that we'll play. So if the user types in, they're going to type a single digit at a time. That's what the state machine is going to run with. If the user types 5, that means the number that they want to check divisibility by 5 of is 5, and it is divisible by 5. So we'll say yes, right? And then we can offer the user the opportunity to get another, or enter another digit, yes? And now they've typed 2 separate digits, but we're going to interpret that as the number 51. And now that number is no longer divisible by 5, right? What's the trick to notice that a number is divisible by 5, by the way? Do we all know it? Yeah, it's to check the last digit. So that's going to be our state machine. Whatever the user just typed, that tells us, now it's 510. Immediately we know that it's divisible by 5, right? Because it ends in a 0. The user types an 8 now. Now the whole built-up number is 5108, and it's not divisible by 5 immediately because it ends with an 8. But if the user types a 0 again, now it suddenly is. Yeah? So the user has given us these digits individually, and we're going to check if that number is divisible by 5. Okay? So here is the state machine that does that calculates that. So we'll say, you can have the not divisible by 5 state, and you can have the divisible by 5 state. Yeah? And I think when the program starts, we haven't gotten a number yet, so we're going to start in the not divisible by 5 state. And then, the second we see the digit 5, right, or the digit 0, we're going to go into the divisible by 5 state, because now we've seen a number that ends in a 0 or 5. Does that make sense? If we're getting individual digits, and we see any of these two, immediately that number is divisible by 0 or 5, regardless of what came before it. So state machines don't have a lot of memory, but this is all we need. We just need the last digit here. Okay? So now we're in the divisible by 5 state, as long as we see one of these, and maybe the user types 55. It's still divisible by 5. You keep on typing 0s and 5s. Yeah? The second it becomes not divisible is when you type something that's not 0 or 5. Right? And it remains not divisible by 5 if you type something that is not 0 or 5. Does this state machine make sense to us? It's just going to run on individual digits, and we're like pretending to build up a number. And so this is something that we can change into code and make a state machine programmed. All you need is a variable to keep track of what state you're in. Maybe we'll use numbers to represent which state. So like, I don't know, this can be state 0, this can be state 1, something like that. And so if we want to start in this state, we better set the state variable at the beginning to 0. And then based on what we see, we will change our state. Okay? So let me do my best to program the state machine for you, and then I'll let you think about a different version of this problem for a little bit. Okay? So I'm pretty sure I saved this. Let us do this. Let's get a number. Well, let's repeatedly get numbers, right? Sensing. So I'm going to, let's just forever keep asking for numbers. That's fine. Enter the next digit, right? Of the number and wait. And we want to like make a state machine. We want to program the state machine. And really, in code, all you need is a state variable and a bunch of if statements. So at the very beginning, we'll be in the not divisible by 5 state, so that's state 0. We will encode it that way, that's fine. And then, forever, we're going to get a new digit. It's going to be placed in answer. And then we're going to run the state machine on that variable, right? So here's what it's going to be. So if, and this is how we'll do it, I guess, if the, I don't know, it's always, is it 0 or 5, or is it not? So is the answer equal to 0, or is it equal to 5, or is it not? So there's that one. There's that one. So yeah, if the answer is 0 or 5, then the state should now be, right? Regardless of where you are, immediately go here. Go to state 1. That's how we'll encode it. So it'll just be like state equals 1 now. Otherwise, state should become 0. So this whole state machine just like squishes down into a single if-else block. Because regardless of where you are, like if you stare at this long enough, it's, all right, if you see a 0 or 5, you're going to state 1. If you don't, you're going to state 0. Yeah? And you can make this a lot prettier for the user. You can check the value of the state variable and print out, oh yeah, that was not divisible by 5, or yes, it was divisible by 5. But we don't have enough time for that right now. I'm just going to set the state variable and show you the state variable changing. Okay? So forever, set the state to 0, and or starting, set the state to 0, then forever, ask for a digit, like, I don't know, 2, and state remains 0, because that digit was a 2. That was not a 0 or a 5. But now, if I type a 0 to mean 20, suddenly, boop, state got set to 1, because it is divisible by 5. I can type 5 and remain in that state. I can type 4 and get out of it, right? Back to state 0, we're not divisible by 5. And the number that I built up was 2514 or something. Does this idea make sense? Translating a state machine to code is not too bad. You just got to keep track of which state you're in and use if statements to like go between states. Yeah? Any questions about this? And you can make it much prettier, like check the state variable's value and say stuff to the user based on it. That's totally fine. Okay? So with that, I would like to give you a couple minutes to think about this same problem on your own, but try to design as a group, like maybe open up Paint or something, try to design a divisible by 2 state machine. See if you can figure out what that needs to be. And that will bring us to the end of the slides. So yeah, get into peer instruction groups, please. Introduce yourself and take a few minutes to talk about how you might create a divisible by 2 state machine instead of a divisible by 5 state machine. Let's remember what those are. Question first. I have a question with the homework. I can answer that after you've talked to your group. I want you to do this. Check if that number is divisible by 2 that the user is typing a digit at a time. What would yours look like? Because you're starting in the middle, maybe it might be easier. If you go back, I also offer just a custom assignment tailored to what your interests are. If you have something that you might want to learn, my only requirements are that you find something new. Not taking CSCI for your program for this class, then yes, you're doing. So if you go to the chapters that I sent to you, chapters 1.7 to 2.1, so let's go straight to 1.7. But if you look there, eventually if you start scrolling, you'll see exercises. All right. Let's come back and see what we're thinking. Do we have any bright ideas about what we could do? What would we be checking? Yes. That again? Yes. Absolutely. You check what digits do we need to check? Like what are the special digits? Yeah, all the numbers that are multiples of 2. Good. So instead of 0 and 5 now, it's 0, 2, 4, 6, and 8 become those special digits that take you between the states. Very good. So for example, like these are types 1, it's not one of these, not divisible by 2. But these are types of 2, now it's 12. Oh man, it's suddenly divisible by 2. These are types of 3. Oh, not one of these. No longer divisible by 2. No longer even. What if they type a 4? that brings us back into the divisible by 2 state. So does it make sense how we would change this using these different digits? Well, that's pretty fun. You can actually create a divisible by anything state machine if the number is in binary. Dun, dun, dun. So, yeah, any last questions about any of this before I talk about assignment and midterm? Okay, so programming assignment. Well, let's talk about this one. This will be due week 9. Give you some time because you still have another one, right? This is your very last Scratch assignment, so I want you to do whatever you want within reason, okay? So you can make a Scratch program of your choice. Whatever you would like to do, you can do, okay? As long as you fulfill these requirements, okay? So have fun with it. Do whatever you'd like. Make it cool. So your program has to have at least 3 key press events that do something when you press those keys, like jump when you hit space or something like we were doing before, move when you press the up key, things like that. So 3 key press events, can be whatever you want. You must use at least 2 conditional blocks. So those are like if then else or if then, stuff like that. Got to use 2 of those. And you also have to have at least 2 looping blocks, like a forever loop or a repeat until loop, whatever you want to do with those, but at least 2 of them. The only thing you cannot do is exactly copy anything that we did in class. So don't make another platformer game. Don't make Pong exactly. But you can totally build off the stuff that I have been going over. Okay? So that is, that's your assignment. And because it's up to you what you're doing, I think it needs a bit longer of a demonstration because I'm not sure what you're doing until you tell me, right? I hope that makes sense. So yeah, that's your next programming assignment. And after this, we will be in Python. Isn't that cool? We're ready to graduate to it. All right. So if we're fine with that, also click this. Reminder, you have a test coming up soon. It's going to be week 8. That was when I promised it. That's smack in the middle of the semester. It's actually a midterm for once. Instead of like weird weeks, like 2 midterms in a semester. We're having just one right in the middle. It's a real midterm. Okay? So all the information will appear in this midterm info, this midterm block on Canvas. Or it's called a module, right? I will release right now this midterm info page, which will have everything that you care about. Okay? Hopefully I made it right. So it will be on the Wednesday of week 8, which is going to be March 2nd, if I calculated correctly, because right now we are here, right? So week 6, week 7, week 8, the latest possible day of week 8. Okay, so just come here and we will have a midterm instead of a lecture. And yeah, the topics are these up to and including week 7, but I won't hit too hard any week 7 topic specifically because that would be evil. Most of the points will go towards an essay question. Okay, so as long as you write enough, then you will get most of the points of the midterm. That's about it. So I just want to see how you think, really. So here is like what the format's going to be. You will see a couple like multiple choice and short answer questions, and then you'll also have an essay question. Okay? That's going to be the format. That's how it's going to look. And what you can do is, what you will be doing, the essay at least is going to be on some topic that is relevant to stuff that we've talked about in lecture and the essays that you've written already, things like that. And then the other problems, it's really hard for me to ask you to do Scratch and like paste that into Canvas, so that will be odd. So I promise to ask you questions only about stuff that I put in this nice little cheat sheet that I have made for you, as far as logic and maybe programming-ish stuff goes. Okay? So here is your little cheat sheet. Study this, and you will do well on the questions that I ask you. Okay? So know your logical operators, wink, wink. Know your logic gates, wink, wink. Okay? Those, you can expect questions on those things. Okay? Makes sense. And then finally, you can use this cheat sheet as you take the test. The test is completely open book and open notes. I'm not trying to kill you or anything. The one thing you can't do is talk to a human other than me while you take it. Okay? Just come here, ask me questions about the questions, and do your stuff. Okay? So that is week 8, the Wednesday. Any questions about that? Yes? Oh no, it's going to be all on Canvas. It's going to be right here when I release it. I'll change it up from what I have currently, but yeah, you'll just click it on Canvas. It's called a Canvas quiz, I guess, if you've taken one of those before. So there will be it's all clicking and typing. Okay, that's all. So that is my plan for the midterm, and that is your helpful cheat sheet. Another question? Yeah, this is an in-person class. You got to be here to take it. I guess technically, if you really wanted to, you could just take it some other location, but it's going to be during class time when it's going to be available. I guess it is on Canvas if you really don't like being in here. Yeah, any other questions? All right, that's all I got for you. So take the rest of the time to do work, ask me questions, and